Okay, hello everyone. Guys, want to take a look at day 46, all right, which is Tuesday, our day back here. This is the 22nd of February, all right. If you're reading this online, I'm looking at it from a little different, you'll get the same material, just from a different class. Start with the homework check. Oh, here. I'll open up a copy of the slideshow. All right. In a separate tab, I do that because it has the answers for us. We'll open up the homework check, take a look at it. And it always starts with the essential question of the day. It's worth 3 points. It's usually the third slide. And this is the copy of the slideshow. It's in the video. If you watch the video, it's right there. Guys, what kind of real world situations can be modeled using quadratics? All right. Number 2, it's saying the vertical motion equation we're using looks like this. Measures the height of the object after t seconds. We'll measure it in seconds. What units are we using to measure the height? Okay, again, if you look at the slideshow, first we go through area of the frame. Right there, we're talking about it right there. All right, then we get to this one here. All right, in feet, it says it right there. Height of the object in feet, okay? All right, number 3. We use a quadratic function to represent the area of a rectangle. There are sometimes values for the area that don't make sense. Guys, why does that happen again? Let's look at this right here. Sometimes there are values that are unreasonable. Right? We cannot have a negative area or a negative sides. The length of a side can't be negative. Right? Sometimes we get that in math. It doesn't apply to the real world. Okay? Number 4. All right, this talks about the projectile motion problem, or vertical motion in particular. Sometimes we get answers that don't make sense. Let's take a look at it. This one right here, guys, this answer here doesn't make sense. Negative 0.9 seconds. Again, we can't have negative seconds. Remember, this guy started here up at 20 and took off. All right, the quadratic, though, in math, will come back and hit in a negative spot here where it crosses the x-axis. That doesn't make any sense in the real world, okay? Can't have negative time. All right, please submit that. All right, guys, that's the homework check. The worksheet, I will print. I will put a key to the worksheet, a copy of the answers worked out. Let's take a look at 46 here, vertical motion. This is the exit ticket. All right, basketball thrown in the air, initial height is 6 feet. All right, so that plus 6, that must be the answer there. Initial vertical velocity of 14 feet per second. That's the 14 in the middle. That's it right there, okay? Basketball is thrown from the air from an initial height of 8 feet. All right, so which one of these is the y-axis, the y-intercept 8? That one's 4. That one starts at 0. That one's upside down. Right there it starts at 8. Right there it starts at 8 and goes up. All right, right there. All right, number 2, I think it's the same answer. I think it's the same graph. Vertical motion. What's the initial height of the object? Right there, guys, 8. See where it starts? 8. That's the initial height where it crosses the y-axis. All right, number 4. What's the maximum height? Guys, starts at 8 and goes up to right there. That's 9, right? Right there is 9. That's how high it goes. All right, number 5. How long is the object in the air? Again, it goes up, comes down. Time is the x. X is keeping track of time. 1, 2. Looks like it's 2. 2 seconds. Yep. All right, number 6. Vertical motion equation. How long does it take for the object to reach its maximum height? Okay, guys, this is negative b over 2a. Right, we did this one before. We'll stop for a second. Okay, guys, I just wanted to get us a graph to show. Guys, how long does it take for this object to reach its maximum height? Okay? As we take a look at this right here, this has exactly that graph right there. All right? Takes off at 48, goes right up here. It hits at 164. The object reaches its maximum height of 64 feet 1 second after launch. It says it right there. So go ahead and take it. 1 second. Right? Of course, it's 32 divided by 32. That's 1. Right, number 7. What's the maximum height? Okay, guys, if we plug in 1, I think we got it there, 64. Yep, 64. Starts at 48, goes up, 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 right to there. That's 64. Okay, go ahead and take it. Number 8. How long is it in the air before it hits the ground? Comes back down, bang, right there. All right? At 30 means the object was in the air for 3 seconds before hitting the ground. Okay? That should help you right there. That's it, guys. Thanks. Again, the worksheet key will be posted.